The first question, question A, says graph the region bounded by the curves of y equals x squared minus 2 and y is equal to negative x. Write down an expression that gives the area of the region and then find the area. Solve this problem without using the GDC. Now, just because I can, let's bring out the GDC. Okay, and let's graph these two equations just so we can know what it looks like. So the first one is x squared minus 2 and the second equation is y is equal to negative x. And we can graph that to see what it looks like. And that is exactly what it's going to look like. So we want to find out the area between that curve. Okay, now it's not important that we know it right now. What we need to find is this point where they intersect and this point over intersect. Now, if you notice here, the line is on top and the parabola is below. So the f of x is going to be my line and g of x, which is below, is going to be my parabola. Now, to do this, I have to find where they intersect here and here. Now, that's not that difficult. Let's try to do that here. We're going to try and do this. Now, how do I know where the two graphs intersect? Well, basically what I'm going to do is I'm going to set both functions equal to each other. X squared minus 2 is equal to negative x. Well, let me erase this because it's bothering me. Okay, now let's put everything to one side, bring the x to the other side, and I get x squared plus x minus 2 is equal to 0. Factor that out, and I get x plus 2, x minus 1 is equal to 0. Okay, so that's going to give me a value of negative 2 and at positive 1. So that curve that we had a minute ago that I just deleted, I should have minimized, is going to intersect at negative 2 and 1. Now that's important because those are going to be our boundaries. So let me clear here. Now that we know it's going to be negative 2 and positive 1, what we're going to do is set up the equation to find the area of the graph, because it says write down an expression. So my expression is going to be the integral from negative 2 to 1 of the top one, remember, was my line. So that's going to be negative x minus the parabola, which is x squared minus 2, put all this in brackets, and dx. Okay? Now, if I simplify it, make it into one expression, simplify the middle, I'm going to get from negative 2 to 1 of negative x squared minus x, and minus a negative 2 would be a plus, maybe, 2 dx. One of these days, I'm going to get it right. I won't have to record on this little phone. Okay, so that's my integral. Now, what I have to do is basically just solve the integral. Now, we know what the integral is here. So what I'm going to do is I'm going to, since I don't have a lot of room here, I am going to clear this and then continue from here. So the integral of this will be -1/3 x cubed minus 1/2 x squared plus 2x from 1 to -2 or -2 to 1. Now, just like we did using the fundamental theorem of calculus, I'm going to plug in 1 for x, 2 for x, and subtract them. Now, you plug in 1. 1 cubed is 1. So let's see if I can get that. 1 cubed is 1 times -1/3 is -1/3. 1 squared obviously is 1 times 1/2 is -1/2 plus 2. Minus, if I plug in -2, I get -2 cubed, which is -8 times 1/3 is -8/3. -2 squared is 4, divided by times -1/2 would be, or positive, -2 squared is positive. 4 times -1/2 is -2. And then -2 times 2 is -4. And when you do the math here, you're going to get 9/2. And that's my answer. 9/2. Okay.